In this video, I am going to define aptitude problems on train. I think most of you wants to know how to do aptitude problems in less time. If that is your case, you are in the right track. In this channel, you are going to view different approaches to solve same problem. I guess everyone like shortcut tricks to do aptitude problems. We have special section for shortcut tricks to do basic mathematical operation. So it's short time. Welcome to aptitude tricks. Now I am going to explain aptitude problems on train. They generally involve speed, distance and time. Usually questions are asked to find out any of these quantities. In the first type involves mainly an object which is stationary. The object length will be negligible when compared to train. It can be a person. For example, a pole, a man who is not moving while train is passing, a tree, a signal post, etc. A question to understand the time. A train running at a speed of 60 km per hour to crosses a pole in 12 seconds. What is the length of the train? Here, the stationary object with negligible length is pole. Second type usually involves a man-made structure like bridge or platform which has got length when compared to a train and it is stationary. What is the length of the bridge? Which a train 120 meter long and traveling at 60 km per hour can cross in 50 seconds. Here, bridge is the stationary object with considerable length. Third type, in most cases it involves a moving human being or something in motion, but length is negligible when compared to a train. A question to understand the type. A jogger running at 9 km per hour alongside a railway track of a 120 meters long train running at 45 km per hour in the same direction. In how much time will the train pass the jogger? A jogger's length is negligible when compared to a train. Fourth type, it's just like third type, except the object should be of considerable length when compared to a train. Most probably, the object is also a train. A 270 meters long train running at the speed of 120 km per hour crosses another train running in opposite direction at the speed of 80 km per hour in 9 seconds. What is the length of the other train? Here the object is also a train. Fifth type. It's a combination of previously mentioned type. For example, the question involves a signal post and a moving man, or a questions with two trains and bridge. A train traveling at 48 km per hour completely crosses another train having half its length and traveling in opposite direction at 42 km per hour in 12 seconds. It also passes a railway platform in 45 seconds. What is the length of the platform? The question involves two trains and a platform. Type 6. It includes two trains. The starting point of first train would be the ending point of second train and vice versa. The meeting point is our main concern here. Two stations A and B are 110 km apart on a straight line. One train starts from A at 7 am and travels towards B at 20 km per hour. Another train starts from B at 8 am and travels towards A at a speed of 25 km per hour. At what time will they meet? The question is about meeting time. So our main concern is meeting point here. Seventh type. It's like sixth type. Here main concern is after the meeting point. Two trains, one from Kochi to Trivandrum and the other from Trivandrum to Kochi, start simultaneously. After they meet, the train reach their destination after 9 hours and 16 hours respectively. What is the ratio of their speed? The question has a statement. After they meet, the train reach their destination after 9 hours and 16 hours respectively. So after the meeting point is our main concern. We need some equation to remember to solve these type of problems. Never ever forget these three equations. No. Only one of the equation is needed. Other one can derive from this. So the equations are: speed is equal to distance by time. The unit of speed usually represented as kilometer per hour or meter per second in train problems. Time is equal to distance by speed. Usually the unit of time represented as seconds. Distance is equal to speed into time. Usually unit of distance represented as meters. Oh, again 1 kilometer per hour equal to 5 by 18 meter per second, or 1 meter per second is equal to 18 by 5 kilometer per hour. Third equation. Use this only for type 7 problems. A is to B is equal to square root of x is to square root of y, where A and B are the speed of first and second train respectively, where x and y are the time taken by the first and second train respectively after their meeting point. How 1 kilometer per hour becomes 5 by 18 meter per second? 1 kilometer is 1000 meter. 1 hour is 60 minutes. 1 minute is 60 seconds. 1 kilometer per hour means traveling 1 kilometer in 1 hour. That is 1000 meter in 1 into 60 minutes. That is 1000 meter in 60 into 60 seconds. So we can write it as 1000 by 60 into 60 meter per second. Cancel zeros. Cancel 10 and 1 6 by 2. We get 5 and 3. So we get 5 in the numerator and 6 into 3 18 in the denominator. That is 5 by 18 meter per second. For all those who are out of touch with math problem, they can do these steps for practicing. Step 1. Identify the numerical quantity along with its unit. Step 2. Convert the unit if applicable. Step 3. Applying the main equation and solve it by simplifying. For those who are good in math or really confident, do all the steps at same time. Convert the unit of given data if applicable and apply the main equation along with shortcut tricks. If you want to understand further, see our type 1 problems on train. If you like this video, please like and subscribe to our channel.